mode as a... It's just started recording, so that's good. So yeah, I'm using stationary modes as a generic term for these, but Sontek call it stationary mode and RDI call it section by section, but it's really the same thing with a different name from the two manufacturers. So I might as well make my slides full screen. I think you can probably see them at the moment already, but I'll go full screen with that if it will play ball. Come on, there we go. Get rid of that thing there, and that there. Yeah, so as this slide suggests, I'm just one of the people who's going to be talking in this. Well, hopefully everybody might have a chat in this, but because of where I am based and the conditions in which I normally do most of my work, which is on the Thames and its tributaries, really ADCPs work really well with bottom tracking for me. So I have to confess, I haven't really done that much with stationary modes, but I am aware they can be really useful and a really powerful tool for helping us in certain conditions where maybe bottom tracking doesn't work, but there are other conditions in which they can be useful as well. So to help us go through this, we have three learned people with a lot more experience than me. We've got Rob Thomson from SEPA, who some of you may have heard from one or two others in this series. Say hello, Rob.
Hello, everyone. Yep, thanks.
Thanks, Rob. We've also got Lee Pimble from Sontek. Say hello, Lee.
Hi, Nick. Hi, all.
Right, and we've got Nick Martin from Xylem. Also, I'm never quite sure on that division between Xylem and Sontek, but Xylem.
We are all Xylem, but
yeah.
But yeah, hello, yeah.
Yeah, but the distinction between leaving, anyway, we won't go into that right now. So they're going to lead much of this. I hope it's going to be really interactive. I hope it's going to be a lot of sort of looking at data, a lot of sort of helping you to understand where you can improve your results with these kind of things. Because I always have to throw a few PowerPoint slides together, I have done so, and if they will advance like this. So yeah, basically, you know, where and when to use them, not just high flows. Hopefully we might see one or two examples of where you use them when it's not in high flows. How to collect the data, sort of practicalities as well as software. I had a quick chat with Rob this morning about, you know, things like, do you always gauge when you use stationary modes? Do you always work from an ADCP or from a bridge, or can you use it ropes bank to bank? Can you use a remote control boat? Some of those kind of questions. RDI and Sontek software, having a look at both of those, any differences between them, basically just how to use them. Processing results, and perhaps what I hope we might spend most of our time on, which is sort of looking at data. And anybody on the call who's got some data that's of interest, you know, we would love to see it. You know, anybody can share their screen, I think, in this session. So if you've got data that's of interest and you've always kind of thought, oh, what about this? Now's your chance to get it looked at. So, I mean, I threw together just a few examples of times when you might want to use stationary modes. But, you know, the guys on the call probably have a lot of better examples than this. But, you know, primarily, you could argue that the main time is when bottom track is struggling or failing. So that could be through weeds. It could be too much sediment in the water column, so it's not getting a good signal off the bottom. It could potentially be that the water's too deep. Moving bed is a key one. If the bed is if the ADCP is detecting bed movement using bottom tracking. Very choppy surface, very rough bed, steep drop-offs, and the slide or the picture that forms the background of this slide is a place called Killington up in the northwest, and we were able to do moving boat measurements at this site on the day in question when we took that photo, but the bottom tracking was struggling. And we tried several different ADCPs, and all of them were struggling slightly. And that's a combination of the slightly rough surface, potentially a bit of aeration going on underneath the boat, but also a very rough bed. We think there's a big sort of fractured rock bed there, and it was causing problems for it. So arguably, probably, a stationary type mode measurement would have been a better solution there. But also, yeah, improving results in very slow flowing water, perhaps understanding velocity profiles, vertical velocity profiles. And I think that's about all I came up with before wanting to hand over to the other guys. But yeah, I just found this picture. It was probably from Andrew Booth, from somewhere up in the northwest. You know, a stationary mode measurement is probably going to be your best bet in this kind of condition, because bottom tracking is really going to struggle when you've got these kind of waves and high velocity water. So without further ado, we didn't actually discuss who was going to start talking when I finished talking, but I'm hoping that Rob or Nick or Lee is going to jump in now and pick things up. Maybe Rob. Rob, would you like to share your screen and take off from here?
I'll certainly have a go. And as you've said, hopefully, if people are keen, take control of the screen and show some data, show us some interesting things. Or I know sometimes people don't want to, but I'll go on for as long as everyone's happy. Just a couple of slides and then data. Hopefully, most people here were present on the previous.
Just before you start, Rob, sorry.
Oh.
Go ahead, Lee.
Okay, so I've got a list of things that I commonly get asked when I travel around about stationery and that. So we'll definitely use Rob's data sets and everything, and I'll just tick off the bits that to make sure that they've all been covered. The most common questions or issues that people come up with, and then if we sort of haven't covered all of those by the time we get to the end, we'll make sure we do get them covered. But I'm sure there'll be plenty more that Rob comes up with.
There you go.
So if that's all right with you, Rob, I'll leave you to.
Slightly intimidating that school teacher Lee is looking over your shoulder going, oh, you only got 12 out of the 19 things.
Yeah, we'll see what we cover. Data, if no one else has any, I should have enough, but we'll see how it goes.
That'd be really good if somebody could bring up some of their own data, that they want to ask questions about. It really is a strong way of learning.
Yeah, completely agree. Brownie points for anybody who chips in and says, hey, look at my data. But anyway, Rob, off you go.
Hello, sorry. I'll start from the beginning. There we go. So, Nick's introduced it quite nicely. And as I was saying, hopefully everyone was here a few weeks ago. So I don't need to go over too much of the things. And we're more looking at the data and software and how to play around with it. We're looking at what Nick's already said we're looking at. I'll just show you this because I thought it was quite nice the other day. I sent this to Martin and up here, like you, we've been having lovely low flows and great weather. And I'm not allowed out like you were discussing earlier. I'm still only allowed to visit sites. I can't gauge, but on my days off, I play around and check out how low they are. So it's been pretty good. So anyway, back to the real stuff. So we're going to look through each manufacturer software options and get to have a little there for people who haven't maybe read either one. Sensor orientation was one of the things that we're going to look at. Tagline azimuth, island edges, compass on or off.
Sorry, just a quick question. If anybody's not on mute who isn't actually presenting, could you go on mute? And JE, whoever you are, we can see your webcam. I don't know if that's intentional, but yeah, we don't need to. We don't want to
just
see you
be careful
or whatever you're up to. But yeah, there. Thank you. All right. Sorry, Rob.
Hi, Nick. No. Sorry, it's Paul Griffiths here. Can you hear me?
Yeah, I can hear you.
Yeah. Sorry, it's a couple of us having trouble getting on. So I think John was one of them just then. So
he's one of yours, is it?
But he didn't realise the other camera on. But yeah, that's cool. I think we're getting there. So, sorry, Rob.
No problems, guys. No, these things I'm just going through here on this slide. These were the things I was talking about a couple of weeks ago. And I was hoping to show you data to demonstrate each one. And these were also things that Lee wanted included. So hopefully we haven't missed too much out. Depth, the different depth sources and manual depths are handy. And as Nick said, we want to use them in high and low flows. And lastly, more of the settings in each one and why we want to use some manual options. Okay, so that's the end of the PowerPoint. I'll end that one in some data. So, we'll start off with Sontek. And first thing I mentioned was my list was orientation, and that the fact that in a stationary gauging, it does matter which way we put the sensor into the deployment platform, whereas in a moving boat, it doesn't really matter. So we said in our presentation that the black plug Sontek or beam 1 wants to be pointing directly out the back of the platform, or 180 degrees to the front. So in this example here, we've currently got the compass on, and everything's looking roughly okay, although I think the tagline azimuth is probably a little bit off. Just tagline azimuth post gauging, it's not best practice, but if you do think it was wrong, you can adjust it here, and hopefully
Rob, do you want to just explain the difference between the blue arrows and the red arrows? Because I know they confuse a few people.
Yeah. The red arrow is the true velocity, so that's what's being measured by the ADCP, the true vector of flow that's going past it relative to it, and then it's projected the normal velocity onto the tagline azimuth, so it's the true streamwise velocity. So if the red arrows are to the side and larger, when they're compensated for being projected through, projected normal should decrease the magnitude a teeny bit. So
and there's a few things that can, I was just going to say, there's a few things that can cause those arrows to not orientate correctly, which I guess you're going to go into later on. Yeah. So one of the things that are incorrect is you've possibly got a compass problem, or you've possibly measured your tagline azimuth incorrectly. But in this case here, just for a little bit, Nick, I'll go on to the arrows. So this example here is for sensor orientation, so everything looks fine. But in this case here, if I was to turn the compass off by selecting X, Y, Z, I'm going to apply that to the whole measurement, everything's going to look wrong. And you can see over here now we have a negative flow. So in this case here, the guy who did the measurement had put the black plug facing directly forwards. So if you did have a compass problem or are going to measure the tagline azimuth with the compass, in this case he just knew it, so he typed it in, you could cause yourself problems. Luckily it was directly forward, so it's easy to fix, but it just goes to prove that you do have to have the tagline azimuth measured correctly and have the sensor orientation correctly to start sorting out your data. Hey Rob, once you've got it there as well, if you just change the tagline azimuth at the top from 188 to something else, it won't change because you're using XYZ instead of enough. We're not referencing the compass anymore, so changing the tagline azimuth makes no difference at all. Yeah. So yeah, just to go to prove. So yeah, for Sontek, directly out the back, for RDI, you want the beam 3 at 45 degrees clockwise from the front of the deployment. I'll just bring a quick RDI example in to show you why that is. So yeah, Stream Pro. So Stream Pro, no compass for this Stream Pro. Okay, so we don't have two arrows like Nick was saying. We just have one arrow because there's no compass. We are not measuring relative to tagline. And if we look at the mean direction, it's always about 135 because 0 for direction is measured relative to the y-axis, which goes through beam 3. So that has to be at 45 degrees to the front of the float.
Can I just chip in at this point whilst we're talking about this? Does somebody brave want to explain why the compass and why the orientation and the azimuth and everything else is so important for stationary measurements? I kind of know why, but I don't feel confident enough to try and explain it with you guys on the call. But
they allow the sensor to rotate freely around in the river and always then reference the true flow, reference the azimuth. So in this case with the Stream Pro, if this sensor is rotating around, it's not compensating for the right direction of flow because there's no compass. So if it was skewed, in this case, we started to mention that in the previous one, but if this actually was that skewed, it's not going to know, and you'd have to put a flow angle correction in here to account for that, as you would with Sontek sensors if your compass was turned off and your float was skewed in the river.
But it's also because it's the X component, it's the downriver component of velocity that's that we need to know to calculate discharge correctly, isn't it? So that, you know, if you're, whatever the orientation of your boat, if the flow at that location of the river is quite skew, as with that first slide where you had the blue arrows and the red arrows is always longer than the blue one, because the blue one is just the downstream component of the red arrow. So it's That's trying right. to, yeah. So it's actually useful if you find one with a greater degree. Oh.
So if you, I was just going to say, if you are out there collecting, I don't know for RDI, but for the Sontek anyway, and you ever want to use it without the compass off, you always have to make sure it's at 90 degrees to the tagline as you're going across. If you are using the compass, we can rotate and correct for that using the compass, but I'm not sure about RDI, if you can do, or you have to manually put in an angle.
If it's not a 90 degrees, then you can apply that correction factor in here.
You could, yeah. Yep.
Yeah. And in RDI, I sort of showed you where it is in there. There you go. In each, and you can apply that correction factor for each vertical, because it will change as you go across the river. It's not a constant, so that's pretty good.
So that flow angle correction, what does it want put in there? Is it a number in terms of degrees, or what does it want?
Yeah, it's degrees or a coefficient in RDI, and in Sontek you can just put it in as a correction factor, which is a coefficient. So if it was 10 degrees, I can't remember what it is, 0.9 something.
I don't know, but
I'm still not 100% sure if that's a fudge or not. So rather than typing what the degrees should be.
Yeah, it is a fudge, Nick. It is, but an angle of 20 degrees will give you 7% error. So if you sort of go back to 93%, 0.93 on there, that will fudge it back to take that 7% that out. But it's not truly measuring what the angle was, whereas if we had the compass on, it would be.
But the important thing to know is when you look at that plot in the middle of the screen, you know, the blue line represents the magnitude of movement of water down the river. In other words, you know, the magnitude that goes into the discharge calculation. So the red line will always be longer than the blue line, and the blue line is the amount of that red vector that's downstream.
Yeah.
And that's why all this sort of heading related stuff is important, because if you don't know your heading, you don't know how much of that red you need to remove, or you know how much you need to shorten the red to get to just the downstream component. Heading is really important, and is a key distinction, I think, between this mode and a bottom track reference mode, where it's all to do with reference boat speed and water speed, and the calculation comes from a different formula.
Yeah.
So it's important.
So if it looks wrong, if you're looking at the channel, you sort of say everything's flowing directly downstream or as good as you can see, and you see that the red line is skewed at an angle, it's probably an orientation or an azimuth issue. Okay, and so that's where you'd need to do your correction from. Unless sometimes you'll see these, and it truly is picking up. Maybe there's a big rock on the bed, and it's actually skewing the flow out at an angle. So just look for that. But if you see that every transect, every vertical, every panel has a angle to the velocity, it's probably sensor orientation or the azimuth of the tagline that's set incorrectly.
Could that one right over on the far left of the screen, the short one, right on the left bank, could that be compass corruption potentially?
Yeah, it could be, but you could look into a different graph there. But the other thing to think about as well, I have seen some sites where they've all been a bit skewed off, and it was the tagline was actually, or the cableway wasn't at 90 degrees to the river, and it calculated correctly actually with it being off, but it was just something else to look out for. Just know your site and look to see what nature's doing in your data.
But yeah, that edge one, Nick, yes, it could be that there's something metallic on the bank, drifting that over. It could also just have been that the friction from the edges, or you know what it's like at the edge. There's all sorts of debris and all that can be at the edge, and so it could just be real velocity.
Yeah.
And your magnetic error is nothing, so I don't think it is.
That's right. Yeah.
Yeah, I was just looking.
Yeah. So if you're measuring without a compass, or with this, in this case, a Stream Pro, because as Nick Everard said, with the difference between the true velocity and normal velocity, you're always going to bias your discharge a bit high, aren't you? Unless you make those angle corrections.
Yep.
That's realise really.
Yeah,
really
that's an important point. Is any error biases it high, doesn't it?
Yeah, that's it. Cool. So I'll bring up another set of data. Nick Martin sent me this one, so because I don't have anywhere with an island, so we'll just bring up this one. So if you did have an island, as in a pier on a bridge or somewhere too shallow to measure discharge, you can put in this island edge thing in here, and it gives you the option to do that when you start a new vertical or station. And in this case, because I've mentioned here, we're on a big bridge with a big pier in the middle and another gap. And if our vectors are all here, look, it doesn't matter if our azimuth is correct or our sensor orientation is correct. We're getting a rate of magnetic interference from somewhere, but it doesn't say we are. There's nothing.
I think it's a G2 compass, so you're not getting any.
Yeah, Ireland hasn't got an upgrade, so it'd be really good for us here. If we look at our discharge 7.3, we should turn off our compass here and observe what the sensor's doing in the river to make sure it's sitting right. But the real discharge is 34.3, and now our vectors look much better with the compass turned off. So that's a good thing. Don't always use your compass, especially off bridges and near the banks. And handily in Sontek, we can turn off compasses individual stations or sections instead of the whole measurement. Whereas in RDI, we only have the option. I know this is a Stream Pro without a compass, but I'll bring up a new measurement. We can only turn it off and on for a whole measurement. We can't apply different things across the river. So here's the data the Sontek guys will laugh at. But in RDI, all we can do is turn the compass on and off for the whole measurement. We can either have magnitude, Y velocity is for snow and ice, under ice, or 2D velocity, which turns the compass on, and we can't apply that per station. So that's a bit of a disadvantage for using RDI.
Have you asked them if that's an enhancement that's likely to come, Rob? Because that seems a fairly
I don't speak
omission, to be honest.
Okay. We never. No, I don't really speak to them. No. They've just released their newest version, haven't they? And it's still there. So.
Yeah. I'll tell you what would be useful as part of this session, though, is to come up with a wish list for RDI and Sontek.
Please do.
These are the things we would like to see, so I'm going to stick that on the list.
Yeah.
Rob, with your data there, could you turn that all back to ENU and then just try and correct the tagline azimuth to get it almost correct? And we might actually see if there is any magnetic interference, even though we don't have a G3 compass.
Okay, so it's a little bit low. Oh, sorry, wrong way. I'll say this site's in Ireland, so I have no idea what it is. We're getting there. 65 maybe.
So what we're trying to do here is just match those red and those blue arrows as best you can.
I love that you can fudge data, don't you? It's so worrying. You can.
So if you look at, I was going to say, if you look at that plot there and the one you have there, and now switch it from that and have a look at the one in the middle, and notice those arrows, the red and the blue, they deviate quite a bit from one side to the other. Now switch it to X, Y, Z. I'm pretty sure we have compass interference at that site, even though we don't have a G3 compass.
Yeah, we do a bit,
definitely.
Don't
we? Yeah. So I would be tempted to, at that site, use ENU. I don't know what, the flow's up 34.394, and then if you change it back, what's it go down to?
goes down a bitty.
33. Yeah, a little bit. So, or you could change those ones on the edge where you think you got a problem and just go for each one and say ENU.
That's it. Yeah. We could have a look at that too, right? Yeah. This is quite a good.
Any questions from anybody on this?
On this one, I've always got a question. If no one else has a question, is there any benefit to section by section when you are like in the middle here? You're coming relatively close, I think, to a bridge pier. Is there any benefit to these modes in terms of the acoustic interference? With the moving boat measurements, we tend to try to stop a certain distance away to avoid acoustic interference. Does it make any difference, or is it exactly the same sort of general rules that you'd apply?
I'll get half the depth width if you could.
These three, yellow beam 4 is hitting, so it's obviously biasing your depth low, because if you were on 4 beam average, it would be biasing your depth low, but it's cutting off velocity measurement to the side lobe of the shallowest beam, so there is problems getting too close over there.
What about in the middle, Rob, by the bridge pier?
No, it doesn't seem to be.
It might be that you might not be, the boat's being dragged all the way downstream in the fast flow, so it's not actually near the bridge pier, although you think it's there.
Yeah.
Yeah, that's a good point. And you have the normal choices of 4 beam depth or vertical beam depth?
We do, and that's applied over here, and it's for the whole measurement.
So can you not select, that's not selectable departure by departure, or panel by panel?
No, it's not. If you double click on, there.
So if you wanted to change to one separate from either of those just for one, or for as many as you wanted, you can put a manual depth in here and apply that.
So on the left there, Nick, you got VB depth and BT depth. You could just type in 2.27 or 2.26 if you wanted to.
In the graph, in the tabular data on the left-hand side of the screen. So,
For RDI, I better be fair to them and mention them now and again. So in RDI again, we can pick. We can have some depth options here for data screening, and they've got these data screening options in here, a bit like Wind River 2. There's various options we can do for quality coding, or not quality coding, but sort of checking the depth, putting some extra parameters of check on the depth in here. And we can also, in each vertical, we can choose its own depth source. So a little bit different again from Sontek, but then you can put in 4 beam average on vertical beam or composite. So that's quite handy.
Yeah. So that I've got one enhancement per manufacturer so far, then, because I've got that one. not the other.
Yeah. Cool. So that's that data set, and this is any other interesting points or questions on this one.
So on this one, what's the water speed? It's fairly brisk, isn't it? Because one thing I notice when I look at this is you see a fairly good picture of the structure of the flow. And I also noticed high velocity extending quite low to the bottom. But one of the benefits of this mode is because you're sampling for a long period of time, you're removing most of the noise from the measurement, so you do end up with a fairly clean picture of the sort of trend in water velocity across your river. Well, that's quite interesting that you can see the structure of the flow, how it changes as you come from the. I keep thinking people can see my screen. It's on my screen, but as you come from the on the right-hand side, the high velocity tends to be towards the top, towards the right bank, and then it moves to mid-depth towards the centre of the bridge pier. So really the learning point, and highest velocity is towards the bottom, just the other side of the bridge pier.
On the other side of the bridge,
Yeah. So you can, when you click on that, you can see that profile. And I'm sure you're going to talk about extrapolation later on, but, when you go back to that one in the middle particularly, the default or the set extrapolation, i.e. the green line and the orange line at the top of the blue line in the top left window, you know, they don't fit very well. You see, hope everyone's looking at the squiggly blue line, top left. When we talk about extrapolation and things fitting, Rob's about to make it fit, I think. Boom, there he's done it. So, you know, he's now fitted that little green line onto the top of the blue line. And the blue line shows you quite clearly that the fastest water speed is down at about 1.2 meters. It's not near the top. So that, you know, it helps you to get a clear picture of velocity profile, and I think helps you to apply a better extrapolation top and bottom because of that nice low noise data. That's you know, there's a consequence of you sampling for how long are you sampling? 50 seconds?
This one's 40
on that one. Yep.
Yeah, we do 50. Yeah, I wasn't going to go too much into extrapolation because you did a very good webinar on it, but an advantage is, that you can get a really good picture of a nice big window and set extrapolations like we've been talking about, the problems with moving boat extrapolations. We can put the right extrapolation for each part of the river very, very easily. So we're not applying constant ones across if they shouldn't be applied.
And you can do that for both manufacturers, can you, Rob?
We can now, yeah. So, oh God, wrong one. So in here, we've now got the power exponent in this box, whereas it used to be in the sort of global processing menu, and we can vary that in here per vertical, that's a new feature for this release, so that's good. And we've got the same options, although there are a couple of extra combinations available in the Sontek software. But yeah, we can apply each one going across the river here with its own exponent. We can't change the exponent of the no-slip, which we can in Sontek in the River Surveyor Stationary. That's a bit of a shame. But
that's going on my list, Rob.
Yeah, so that's in here now. The other thing I was going to mention, things keep coming to me, is this nice bit in the middle. I did mention it in the presentation, but it's telling us here how much percentage of the total flow is in each station, which is really, really nice and helpful for your procedure not to bust, certainly 10%, but aiming for 5% per station. And that comes in the system, and you pop it in the quality settings. So if you know it, stick it in there, or take a rough guess as you're measuring, and it'll start to show it for you. Or you can pop it in afterwards. You can also view it roughly in there. Oops, sorry. But it's nice to have the graphic, but if you've forgotten while you're measuring, you can view per station a flow in this panel here. So you can start to work it out, whether you need to chop these up. But you want to see, certainly aiming for less than 5, not busting 10%, and also not just percentages, but gradual colour changes are nice too. You don't want going purple to yellow, even if it isn't 5%. You try and chop up the river a bit. These can be, sort of every 2 meters if it's a channel like this, but they should really reflect flow and also the geometry of the bed, so this should be sort of irregular.
It's based around ISO 748. So, if you think around your ISO 748 and how you would apply that for a wading measurement or a point velocity measurement, that's pretty much what it's trying to do. Yeah,
it is available in the RDI software. I can find it. If anyone knows where it is, please tell me. But I can't remember where it is. You can put it in and get the same sort of graphic, but it's in here, isn't it? There we go. So it should be there. So it should be showing it, but it's not. I don't know why. I'm not going to investigate too much now because it won't really help the presentation. But it's
down the bottom, Rob. Yeah.
There it is. There you go. It's down the bottom. Same sort of thing. In Sontek, we could adjust that. This is another point for Sontek. We can change it afterwards, so we could make it different, and it'll change the values in here. In RDI, can't, unfortunately.
So, Rob, you just change that to what the flow was in our one?
Yeah. So I'll just like 46. Nothing's changing. It won't let me. But in Sontek, what's the flow? 33.8. So, it doesn't. above 10. And now, still below 5. Oh, a couple have gone up to 5. Look, oh, well done. Yeah.
Rob, can I make a few comments about this little bit of data here? If you just change the track reference to bottom track, if you do that, you can then just see if you have a moving bed. So it's quite a nice, easy way to see if that flow goes down or up.
Yeah. Okay. So
and why we would use it.
It went up.
It went up. Okay. So just that might indicate a bit of boat movement, possibly, when they were doing it. And also with the profile being so flat, if you were to go there and do a current meter gauge and only 0.6 of the depth, they won't agree at all, because it's such a strange profile all the way across the river.
Yeah.
But I mean, that's an interesting one, Nick. Do you want to talk a little bit more about why you might ever want to use bottom track when we're using a mode that doesn't need bottom track?
Why use? So some people use it for, say you have a remote control boat and you want to try and hold position on there, so it might be moving around a bit backwards and forwards. Stationary requires the platform to be stationary, hence the name of it. But if it's actually moving around and you don't have a moving bed, then you might want to be using bottom track for your reference. And it's really useful in low velocities when there might be a wind and it's blowing the platform around out underneath the cableway and it's drifting about, or sometimes a remote control boat when you know you don't have a moving bed but you still want to use this method. It's useful as well.
Okay.
Maybe your boat's rotating a bit.
Could you use GPS? GPS doesn't appear to be an option for
not
a
yet.
track reference. But
no, not yet.
Because wouldn't that be a better solution?
Yes, and we were going to do it, but we haven't. So
okay. You can have that. You can have that tip from me. I'll put it on my list. GPS track reference.
Yeah.
That's 2 each so far.
Always good to have the customer suggesting these things rather than us. We tend to get overruled some of the times. Customers just not so often.
We'll send you the bill for this customer workshop clinic for enhancing your products later.
So I was just hoping I had
a bit messy.
But I don't.
Is it Forest?
It is, yeah. No, I don't. Sorry. Anyway, I'll just get rid of them because we'll skip them later. So, okay. Happy for a bit more data if we get another one. Let's see what's next on my list.
I would be really delighted to hear from somebody else on the call when we look at the next set. I won't be upset if you shut me up and start asking questions instead of me. So somebody else, I'll pick a name if nobody jumps in and asks all the questions.
There is one button, Nick. I'll just jump in there with Rob. If you go back to our software, that when we get data to process, people ask us to look at it. There's a little button up in the top right that says reset to field, because we don't know what you did. So this is how they collected it in the field, and it's quite useful to see what happened when they were out there.
Yeah.
Just remind us why that looks so ridiculous at this point, Nick. It's just compass, is it?
No, they put in the wrong tagline azimuth on this one. And I don't know why they said it wasn't working. You just needed to change the tagline azimuth.
And the azimuth was off by quite a lot, I'm guessing. What sort of 60%? 60 degrees or so?
I can't remember. Was it 80? Was it 50? Did you put it?
It was 335 and I changed it to 60 there. But I think that's a good point, and I brought that up in the presentation. If you do make all these mistakes and it looks crap, just keep collecting it, and mostly we can fix it in stationary. It's really good.
Yeah, I think this one was a bit of a combination between it's got an old compass on it, so it's a G1 or a G2 compass, which means it doesn't collect this magnetic error, which we can then use to say that we got any sources of nearby ferrous material. So we don't know that, and without that, it does look a bit suspect. So by tuning it the way that you are, looking at the tagline azimuth, and then seeing if there's anything weird going on, and then comparing it to the XYZ, we get an idea that maybe there is some compass interference. So that's one of the reasons it's so far off, and they couldn't quite work out what was going on.
Cool. I'll open an RDI file very quickly, which is the one. In fact, we've already got it loaded, haven't we? So just have a look in this software. It's a bit of a simpler, if you like, software package. There's not quite as many options in it, I don't think. We have an information sort of tab here where you can put notes or see what sensor it was and how it was set up. We then have the sort of processing or visual tab, and finally a sort of a samples tab, which is quite useful for checking sort of consistency of velocity direction, sort of velocity coefficient of variation, widths, areas, all those sort of things. And in this tab, you can decide whether you want to include or get rid of a station. In the main tab, there's not as much to look at, but there's a couple of nice features. Intensity is the same as SNR sort of thing. Well, it's different. This is quite nice in your velocity profile tab, in that you can customize the sort of background display a bit like in QRev for medians of all your samples. So if we have a look in there, if I can remember how to do it. X-axis. Where is it? No, I'll try and remember where it is. If I can't, I'll come back to it. It was, but basically I've got it there. So these are dots, and these are medians. So each of these dots represent one of the station samples. So in this station here, we've got 50 seconds duration, but because it's RDI, you won't get a 50 for good or bad ensembles, because it'll be changing its mode. So it doesn't sample once a second like Sontek. It could vary. And out of these, we'll see all the ensembles answers. So if these are spread out, it's not a very stable site at all. And if they're narrow, then you get a good average. So that's quite a handy thing, seeing how sort of reliable your data is. Like Nick was saying, sampling for 50 seconds can often clear up horrible velocity profiles and things like that. But that's quite a handy thing in there.
That doesn't clear up that big green stripe, is it, near the surface?
Clear up this big green stripe, which is a horrible, crappy RiverPro phenomenon, a River Ray phenomenon. And the reason I brought this up was not to say how terrible it is, but just to show that in this new software now, we can cut top bins and cut bottom bins, whereas we never used to be able to do that. So in this case, we'd want to get rid of, if you wanted to get rid of that, but you can see on every single panel, look at the mess of velocity profile it's giving us right across the river. It's horrible. So if you wanted to get rid of that, we could have a look at the difference in flow it makes. So the total discharge of 46 at the moment. If we cut 4 bins, we'd have to do it right across each river and right across each panel, but it would start to I think I've brought the flow up already a little bit there. I'm not going to do them all, don't worry.
So is there no apply to all on that then, Rob?
There isn't. No, I can't apply to all, which is a bit of a shame. It's another thing for you. But the discharge now is starting to creep up, because we're getting rid of this negative impact here, and bringing well, in this case it's still set on power, but the real discharge and then the extended power curve right up. Whether it's correct or not here, I'm just showing the capability of doing it. I'm not saying I would. I'd have a bit more investigation, but the capability of clearing up the data there is within each vertical. And in Sontek it's there too. So you would use screening distance for the top, and if you want to get rid of any of the bottom data, you use it in there and get rid of it. So if we did it here, if we got rid of it.
Hi, Rob. It's Ian here. I just wondered, have they done RDI looking into that at all? It seems like lots of people have asked that question about that line coming through, and they don't seem to be doing much about it.
No, I don't think they are. Nick might know more. I haven't heard anything. They just seem to have left it and pretended it's not there.
Yeah, they do. They tend to sort of go, oh, really? Yeah, no one's mentioned that before. So yeah, I've added it to my list again. But you're quite right. So for anybody who on the call who doesn't have experience of the RiverPro ADCP, it's a good ADCP. if you got one, it would feel quite similar to your Rio Grande and your Stream Pro. It has capabilities that kind of go across that pair of instruments. It's got automatic configuration like an M9. And it produces nice data for the most part, but it does have a tendency to produce weird data at the surface and also close to the surface. And in this example, in a moderately fast-flowing river, it's come up with this stripe, which is just erroneous. I will often say in my ADCP training, if you see something that looks bad, it probably is bad. And, hopefully your understanding of how a river flows leads you to understand that a big green stripe surrounded by water, uniformly green stripes surrounded by varying degrees of much faster water immediately above and immediately below can't be right, and it isn't right. And as Ian's just pointed out, we've known about it for quite some time, and RDI just haven't fixed it. And I think the reason it happens is if you look at the plot, the intensity plot, top left of the graphics, you can see they use a different configuration of ping to get smaller cells near the surface. So they're trying to give you better data near the surface. So they use a different configuration of acoustic pulse to try and get you data near the surface. Then they switch to something else for deeper in the water column. But either at the transition or for whatever reason, you get this glitch. So, so you're probably, as Rob has just demonstrated, you're probably better to reject that data and use the data beneath it, because it does tend to bias you a bit low otherwise. But, really, the reason a lot of you probably don't have any experience with River Pro is because we haven't really encouraged you to buy the River Pro, because it does have, despite being a very good instrument, it has a few rough edges that we would like to see resolved, and we're kind of keeping our purse shut until we see some of them resolved, if you like.
Yeah, that's great. Cheers, Ian. While I'm in this software, I'm going to open one more file just to show you another thing of River Pro data and the little problem that we get sometimes. I can see it here on my, there we go, vectors. So sometimes with River Pros and Stream Pros, we get these, oh dear, that's good data. I didn't want that. That's not too bad at all.
I was going to say, that looks
good. It's lovely. I can't see much wrong with that. Is that River Pro or Stream Pro?
I'll try and make it work.
Which instrument is
Stream Pro?
Oh no, isn't this file at all? A disaster. Let me just see.
So just to prove that, we're not just going to say rude things about RDI instruments. They can produce lovely, really, really nice data, as can the Sontek ones. But that stripe is, it is a bug.
Yeah, I might have to. I might have to abandon this little topic. No, I can't find it. Open measurement.
What were you looking for, Rob? Because I've got a few files on mine.
What I'm looking for is sometimes you get a really
you're breaking up a bit, Rob. I don't know if you.
It's not there, is it?
It might be terrible.
That shouldn't be there. It shouldn't suddenly get really fast. I feel like.
Is somebody not on mute apart from Rob? There's some sort of clattering going on. So if anybody's...
Oh, sorry, it's being bought delivery by my kids.
Oh, honestly. Yeah. I think I have the power to mute you if you misbehave.
You're getting a really fast cell right at the bottom. I'm not entirely sure why that happens. I've got an idea, but I'm not going to go into that just now. But it's a good idea, really. We don't want this horrible fast bit down there. It's not horrendous in this case, but sometimes they really are, and they get a big vex when it goes in the wrong direction and all sorts of things. And to get rid of that, we can just go into processing. And what we're wanting to do here is use this good ensembles in cell feature. So what we're telling it there is it's sat there and it's measured there for 50 seconds. There's 71 good ensembles, no bad ensembles. But if it's got one good ensemble in a cell, it'll give you a velocity for that cell. So we just want to check, let's see how many ensembles it's got in there. And I reckon if I put 2 in here and apply, then that's gone away now. And that'll get rid of that horrible bit of data there, because you're needing to say, no, I'm wanting more measurements in that cell for you to give me a velocity from it, and it hasn't got any more, hence why it has that horrible, bad, fast value. Does that make sense? Hope so. I
was just trying to get my head around that, and I was just commenting, but I was on mute. So it basically, because it's right at the bottom of where it can get data, most of the time through the measurement, it didn't get any data. But for 2 ensembles or 1 ensemble, it got a reading, and the reading was pants.
That's
and you've just said, okay, if you've only got 1 ensemble, don't use it. You need to have 2. So probably it's better to set that threshold to more like 20 or something, isn't it?
No, it can only be set from 1 to 5, I think. You can't have 0 data. But yeah, so if we just set it to 2, I always just creep it up, and it's gone away now. And while we're in here as well, so we can, if we look at screen depth, is taking out spikes using the 4-beam average. So if one of the beams is 75% different from the others, it'll get rid of that depth. Use weighted mean depth, or screen depth using bottom track velocity. So it's saying, well, I've got a depth, but do I have valid bottom track as well, even though I'm not using it? It's an extra sort of parameter saying I want to use that depth if you're getting horrible results. And over here, like Lee was saying, you can choose to use bottom track as your reference if you've got a lot of boat movement and no moving bed, or to test for moving bed. And velocity method, if I have compass problems, I just select magnitude, press apply, and now we'll just see I've only got the one kind of vectors because the compass isn't being used. So, like I said in the presentation before, if you select 2D velocity, your compass is on. It needs a tagline direction. It can't measure it. You'll have to just stick that in from other means like Google Earth or a compass or a guess, and then fudge it later. If you've done it from Google Earth, make sure you put, well, either correct it for magnetic variation or put it in there to correct it. Okay, that's enough on there. Anyone else having a go yet? I can keep going. I'm quite happy, but no.
Yeah,
okay.
I'm just having a muck about with section by section. You can bung that good ensembles in cell threshold. I've gone up to 50 and it's still working. It's thrown out tons of my data. It's not a good move to go to 50, but
all right, it was 5 for some reason. I don't know where I've got that from.
Because that was a very useful bit of learning, because the data I'm looking at, which is one for me, and it had an erroneous high velocity at the bottom, and I've managed to get rid of it.
You can get
that same screening.
While we're talking about it, sorry, Sontek guys, but while we're talking about it, we can also screen our data like we can in Wind River 2 and use 3-beam or 3-beam solution for water track. The other thing we can do is play with our thresholds for error velocities, like I said about the QRev webinar. But what you set them to is pretty hard to work out from this software. You really is trial and error until it looks right. But you could export this data into BB Slice and put it in Wind River 2 and then work it out, but it's a big pain. There's not much else to look at in this software. There's not the options that you have in Sontek. We can view velocity or error velocity. So if you had a patch with a high error velocity like that bit there, that might give you a clue of what to get rid of. Up here, we can not view anything else. Up here, we can view correlation. Very quickly for correlation. Correlation is a measure sort of that's only used for certain types of data. So it's used for all RDI data and HD data in Sontek, and basically it's a measure of if you think of when it's not using IC data or just pure frequency shift, it's sort of taking an acoustic photograph twice and matching up those photographs. So it's a sort of percentage fit of how good the two photographs match each other. And I'm not going to go into any more than that, but it's available in Sontek, but only for HD data. So in all this is IC here. So if I try and plot a correlation, because it's measuring it in a different way. Any more information on that, you can ask Nick. He's got a great presentation with antelopes and things. So.
Oh, that one.
You remember that one?
I haven't shown that one for many years. Oh, gosh,
I
subjected you to that.
Yeah. So, yeah, cool. Right, so what was I getting? Yeah, I was going to show you low flows. We got about high flows and Nick's high flows, but I'm going to open River Surveyor here and just show you a problem I had measuring a sort of a low flow while I went stationary, basically. So desktop, yeah, low flow, moving hard. Yeah, so these are the two transects here, which I got at Forest. So we'll just use this one. So this one here is a pretty wide river. It's about 50 meters wide, really, really low velocities here. And I've got some red, which is caused by flow disturbance from me actually having the float, the torrent board in the water. These aren't real velocities, and they're messing it up and adding to my flow. And if you look at my transit duration, I've nearly 12 minutes. So I did one 12-minute transect across, one 12-minute transect back. I couldn't get them within 5% without I just couldn't, even with an awful lot of processing. So it's not the time to be trying to do potentially 8 transects. You'd be there over an hour and still maybe have quite a lot of mess. So that's why I switched to stationary in these sort of conditions. This isn't the best example of the transect for there. I'll see if the other one's a little bit better. But which one is that? That's 3. You get 708. Yeah. So no. There we go. So yeah, one stationary gauging is going to take less time than doing 2 transects and not having you gauging within 5% and a load of mess to try and sort out. And you can see my problems. I've got flow down here with really sort of meandering, slow profiles. It's only going up to 10 centimeters a second, and back here I've got negative flow. I've got sort of, the flow's not big. Look at this. It's not behaving itself. So the best thing to do is to go stationary and try and average this rather than completely busting 8 transects and spending hours. So yeah, really good for low flows. It's actually better now.
A really important point just to make is that I think it can be a perception that it takes a long time to do a stationary measurement. And as Rob just points out, if you're having difficulties, it can actually save you quite a lot of time. And also, if you do a whole bunch of transects and then you get back to the office and you spend 2 hours trying to make sense of them in the office, that's all time. If you can actually get it nailed in 25 minutes on site and then process it in 10 minutes, that's an awful lot quicker than spending the time getting bad transects and then trying to make sense out of them.
There is, as I was saying, sorry, I think we got cut off together. There is a very good call here for moving location. And now with the RQ pods or the ARC boat and the extra capability of GPS stationary, I would go downstream and do a GPS stationary down there, which I do fairly often now, rather than this location. All right, I've got data, but it's not the best data I could possibly get, so I can get better data downstream where the river's shallower and flowing a bit better, even though I don't have a cableway there. I still wouldn't use moving boat. That's the point. I would go back to stationary there. Even.
The vectors in that graphic that we're looking at the moment, because they look quite wayward, especially those 2 that are crossed.
They're going all over the place. Yeah, that's what I mean about the location. If you look at my flow, it's 2.3 QMEX for the River Findhorn. It's pretty madly low. I think it's about the lowest ever got, actually.
What are the velocities there, Rob? Are they around about 10 meters? Are they around about 10 meters? So
yeah,
so you've got
8 centimeters a second.
8 centimeters a second is tops. 4, 5.
Yeah.
Okay.
So the arrows will go anywhere, won't they? So
in 3 meters depth of water, 2-3 meters depth of water.
Yeah. No, it's a challenge.
Turbulent scales are greater in slow-moving water than they are in fast-moving water.
Yeah. Cool. Well, well, I'm running out of data, but I've got a little bit more. We'll have a look at why you would go manual configuration, because that was a big thing that we talked about the other week, and Lee really wanted to get it included. So off for me. Where has he put it? Sorry, I'm looking at the wrong file. Go away. Right. That one. Okay. So here we are at Forres again, and this time with the river that had 2.3 kilowatts, it's now got 407. So pretty changeable place, and we've got all these nice velocities here, and this is it's a good stationary gauging. There's nothing much wrong with it. The only thing I wanted to show you here is if I go to SNR, any beam will do, and as we go across the river, as I go across here, sorry, I'll turn on something that you can see here. It'd be better than oh God, not that. Some of these just in SNR. Right. So this is telling us what sort of data we're pinging in. So as we go across, we're in 3 megs, and you can see there's a sort of high SNR at the surface, and it's decreasing, especially as we get over here. It's only really just seeing the bed with the water tracking pings. You're getting a little kick off the bed there. It's getting pretty low, and you can see down here now it's getting pink. It's the SNR now is 5. It's getting very, very low, and all of a sudden here, because it's deeper, it switches to 1, and the SNR kicks right up into the blue here, and the SNR is now 26. So it times it by 4 or 5, and just with the change in frequency. Now I didn't tell it to do that. Luckily, it's over 5 meters deep, and it did it itself. But if it isn't 5 meters deep and you're getting poor SNR, like I said in my last presentation, go manual config and just do your whole measurement in 1 megahertz in these sort of high sediment, high flow conditions. That's a real kick up in the data there. So there we go. Horrible SNR, great SNR. But that one now even better. Big strikes off the bed, and then crap again because we're back to 3. So just to show you that it does make a big difference depending on what frequency you're pinging in. Not a problem for your bottom track pings, because as soon as it's 0.8 meters deep, it's in 1 megs, but your water track won't change until it's 5 meters deep. So that's probably not going to be many rivers. You're going to have to tell it to change. Well, not many rivers that we use anyway. So I think I have I'm not sure if I do a moving boat gauging to show the same thing. I don't know if I do. Yeah, I do. Here it is. With one of these. Apologies if you've seen these before. Some of you will have. So we look at this one. Yeah, we'll change that to. So we're in 3. So 3. It's okay. 3 across on that one, so it's going down to about 20. Nothing wrong with this data. I'm just showing you what happens when you change to 1. So that's in 3 megahertz. That transect. That's in 3 as well. That one's not in any. Oh dear. I might be behind there. How do you get rid of that? Here we go. More data. There we go. So this one now. Get rid of that thing. Now we're in 1 megahertz. Same measurement. And look at the difference. And you don't even need me to show you the beams. You can just see visually how much stronger your acoustic signals are in a 1 meg rather than a 3. It's incredible, the difference. So,
did it make much difference to discharge, Rob?
No, it didn't. That's what I was saying. I did this just. But you can see here the beams are starting to struggle a wee bit right over here.
Can we see the velocity plot though? Just for interest and.
Velocity plot, just the speed here, do you mean?
Yeah. Oh, so it's quite.
Well, it's a different scale. I'd have to rescale it because that one goes to 4, that one goes to 3.
Yeah, because I guess I'm just surprised because I don't have rivers that are flowing anything like as fast as that. So I'm quite surprised that it runs 3 megahertz in that depth at that water speed. But
yeah, below 5 meters it will be running the 3 meg. If it's above 1.5 meters a second.
Yeah. And I mean, probably everybody on the call is aware, but the moving bed aspect of this, maybe you can point at it, Rob. So the purple line that... Oh, you explain it. I'll shut up.
No, yeah, hopefully you all saw the moving bed. Yeah, so luckily here I have great GPS, so no problem. I don't need to go stationary. At this flow, when it gets even higher, this place does get higher than I stationary. But yeah, it's no problem with GPS here.
But the clear indication of moving bed that you get just from the transect is the fact that the bottom track reference, the blue line there, appears to have moved way upstream. That the boat will have finished on the bottom of that plot. Oh, the other way around there, but on that one. Oh, there. So it started at the bottom and then it's finished in the middle of that plot, but it's moved upstream. It thinks it's moved upstream, and you can see also from it the distribution of the moving bed. So there's not much bed movement in the first half of the river because the blue overlays the purple. But then there's a strong movement, apparent movement upstream of the blue line. Yeah, that's it. And then it gets slower again towards the far bank as the angle becomes closer to the angle, the true angle as reported by the purple. So that's, if you've got GPS operating on your M9, and I'd encourage you all to have it operating all the time, even if you don't reference to it, if you see the bottom track deviating strongly away from the GPS, like you're seeing here, and the GPS clearly reflects the course that Rob took across the river. I mean, if you know you'd moved way upstream, then you might be right. But if you know you've gone from bank to bank like the purple line, but you're seeing the blue line, that's a really clear indication of moving bed right there. That's about as strong as I've ever seen. Did you quantify it there, Rob? How fast? What was the magnitude of the moving bed?
I haven't, no, but what's interesting here is, this is why I don't bother with moving bed tests, because the moving bed isn't constant in the same place or the same magnitude. So there's no way you're going to correct your discharge using it. And if you didn't do the moving bed, like you might do the moving bed test over here where it's deep and fast right in front of you, and there's no moving bed. So if you haven't done it over here, there's no point. So, yeah.
Exactly. And so we're talking about moving bed, but actually, moving bed is one of the problems you can solve by using stationary mode. So, it's very relevant to this, and Rob's quite right that, when you do a moving bed test, what you're doing, unless you do the lube, which has its own problems, you're doing a series of stationary measurements. If you did enough of them, you can piece them together to get discharge.
In the Sontek software, if you do the SMBA, the stationary moving bed, it will recommend that you do a minimum of 3. And you do each one for 5 minutes. So great, but there's 15 minutes gone. You could have done your whole stationary measurement in close to that. So just do a stationary measurement.
Yeah, so that I think the more I see of it, the more I'm inclined to think that, and this is at a discussion point, I'm not making this statement for just to tell everybody, but I get the impression that using stationary is probably the best solution most of the time when you've got moving bed. Would anybody disagree? Or, I mean, please do if you because I don't have moving bed generally in my rivers.
But he's got a really good GPS measurement there, so that's worked well. So if you've got GPS and
there's a lot of stripiness in the data. Is the data currently referenced to GPS or to bottom track?
It's referenced to bottom track.
I'd reference GGA, applied to all. There we go.
Look at that. You remember what I will so often say is if it looks bad, it is bad, usually. And the bottom track reference data was full of stripes, and those stripes are caused by the fact that bottom tracking wasn't working well. So when Rob switched to GPS, which was good GPS data, all the stripes disappeared. And as long as you don't have any heading errors relating to GPS, then, as Lee says, that's now a pretty good measurement.
But points it out, I use GPS compass, there we go. And that one first is not part of them because it doesn't have the right alignment. But I use GPS compass here for my discharge because there's a lot of metal in the near bank. There's huge big steps and some other things, and GPS compass with good GPS. If you didn't have that,
could you show your time series with the mag error on it? Because you got the compass at the top, which is a great indicator. You got 41 out of 44.
Yep.
But in the time series,
a lot of problems with the metal there. what have I got? There you go. Pitch and roll's busted. GPS quite. So you want mag error? Yeah, left axis.
Yeah.
Go near bank. See. A GPS compass is great. Yeah. Cool.
Can the GPS compass be used for the heading in a stationary measurement?
No, but we've asked for it.
Will I put that on my list? I'm going to put that on my list.
Please do.
Yeah.
Cool. So I've got one more data set, which is working out pretty well, I think. What have I got? I've got manual depths. Yeah, very important. Here we go. So it's not the nicest looking gauge. This is a high flow off. Well, I can sort of show you where it is. I meant to do this for other sites, but it's a bit late now. But if we go to Ward End, this is a little tiny river out the back of Forres. And I really wanted a high flow here, and a high flow here is probably about 10 QMEX. It's nothing big like with the data we've been looking at before. But this is our bridge. Downstream, you can't quite see it here, but there's a weir. So I can't gauge off the bridge downstream because the weir's literally there. Looking at the bridge, you can already see loads of metal. There's tons of metal in the banks here and in the bridge. So I'm going to get compass problems. So I can't use my compass. I can't use a moving boat in the trees because of moving bed and trees. So I can't use GPS. So the only option here, apart from surface velocity, but the only option here with an M9 is stationary gauging. And I managed to get a stationary gauging off the front of the bridge, which isn't usually very successful, but it was in this time here. So I'll show you the data. Let me just shut it down, and then I won't be chasing through the wrong file. I'll just get the right file. Stationary manual depth should be this one. It isn't that one though, is it? Dear. I'll find it somewhere else. Don't worry, I have this data somewhere. Should be this. Doesn't look right at all. That's the second time this happened to me today, isn't it?
If you got your scale set to manual, is that the problem?
It's still it's 14 metres wide. It didn't look 14 metres. I don't know.
No, it's not. It's the wrong data. That is the wrong data too. I'll find it. We'll find it.
One thing, whilst you're finding it, we could mention as well is the importance of keeping the pitch nice and level or as level as you can.
I was going to say, Rob had that really good data set that stumped.
Yeah, I wondered if you wanted to talk about that or not.
Unless one of you two wants to talk about that. So this here is the gauging I'm talking about. Okay. If we use Nick Martin's trick of going back to field, we'll see what a mess it looked like in the field. So this is what I came back with, but I sort of knew that it was good. So I've got the obvious problem with the vectors because of all the magnetic interference, and I have horrible big spiky depths caused by multiple reflections of the vertical beam because it's sort of defaulted to, or had it on default vertical beam primary. And if it gets one of these horrible reflections, it thinks it's real and gives you this mess. So first of all, I'm first going to use 4-beam average. Now we've got gauging.
S5? Or,
no, M9. Yeah, okay. M9. I see a lot of spikes with the vertical beam on the M9 like this.
Yeah, they usually go to about 80 metres or 60.
Yeah, yeah, they make a right mess. Yeah, you can't take them out. If you wanted, if I wanted to keep using vertical beam but just take a bit out, I couldn't. So we looked at that in QRev, didn't we? But yeah, so now I've got the right channel shape. I know I've sort of busted the rules by only having one velocity depth cell, but this was sort of a high flow, and it's the highest flow we've ever got there. So I wasn't too concerned about that. And then the other thing we want to do is turn the compass off. So we've sort of started to fix it. And if we turn our compass off for the whole measurement, because it's all rubbish, then we're going from 3.4 QMEX to just under 8 QMEX. And we've now got a decent usable measurement for my sort of high flow rating there. And because of this measurement, I managed to pop in an IQ Plus and calibrate that and index it. So now we're getting sort of flows from the site. So yeah, really useful. And if it looks terrible, keep collecting it. If you're getting data, then probably we can fix it.
Hey Rob, was this the site where you also tweaked the station samples? Because it says 50 at the moment out of 50.
Yeah,
there was one site that you
samples tab.
Oh yeah.
Yeah, then there was one site you showed us. It was going down to 12, 13, and you then just entered the depth manually.
I don't think it's this one. Because they all look good, don't they? And I haven't done that. How can I reset to field, didn't I?
Yeah.
Yeah.
But you could just show how to do that anyway.
I could. It'd be better with a data set where it was.
Correct. Yeah, I agree.
Yeah. I'll load another one. What's this one? This one is doesn't say. Great. Hang on then. All right. Well, we'll load it.
You put a screening distance on that one.
Yeah, I put a screening distance on that one. I don't know why, because I don't know where it is, Lee. Sorry.
Okay.
I'll get you one. I'll get you another one because you probably want to show it. Here we go. So this is the one you were talking about. It's one of these ones with the mad pitch.
Yeah. So this, to be honest, this stumped me and Lee and a few other engineers at Sontek for a few days. We were trying to work out what was going on. And at a first glance, if you change that bottom plot down there to SNR, Rob.
Any beam?
Oh yeah, any beam. Yeah, not bothered. Yeah, so Rob came to us and he said, "Oh, it's not right. The SNR just doesn't look right when you're not calculating velocity in."
And look at that velocity profile. You know, it's
weird, and the SNR profile is weird as well. And it just stumped us. I lost almost faith by thinking, you know, if the SNR is wrong, we measure velocity right when the SNR, even when it falls away. So it can't be anything to do with SNR, but it kind of looks like SNR is a problem. So it confused us for a long, long time. Anyway, so we looked at this data in a bit more detail, and if you can look down on the left where it says compass, have a look at the pitch. The pitch is around 17.8 on this.
Go to just do a different vertical. I just showed a different pitch, 14.8 there.
So
where it's saying minus 14.8, is that
pitched up? So
nose
the
up.
Nose is going up, nose up. So that has quite a few consequences when you start thinking about it. The beam angles on the Sontek are 25 degrees. So if we got a pitch of 17 degrees, maybe 20 degrees sometimes, one of those beams, the back beam, is almost pointing straight down to the bed, and it's not going to be measuring any Doppler shift at all because it's at right angles to the flow. It's like holding a speed gun at the side of a car as it goes past you. You can't measure the speed of that car. So that's one issue. And the other issue is, do you want to say, Lee, or not?
No, Karen. Yeah.
Okay, with the cell mapping. So we don't do cell mapping. So we measure velocity correctly in each cell, but they might not be in the right place in the water column because they're not corrected for pitch and roll. Even if there were, it wouldn't matter because one of those beams is going right down to the bed, and you're not measuring Doppler shift correctly. So at this site, there's only two ways of correcting this data. One is when you're on site, make sure the pitch and roll is generally less than 10 degrees. You should be okay. Or there's a fudge that Rob does, which is quite cool, to rescue this data, which you do. So, do you want to go through that, Rob?
I will. So before I start, everyone, I know this site has high velocities all the way down because we have lots of current meter gaugings that were done very well to show that both slightly less than this stage and higher, there's higher flows than this is reporting. And down here somewhere at 0.6 depth, there's higher velocities than this data is all showing. This velocity does not look right for a high flow gauging at this site. So
could you switch the velocity in the bottom plot, Rob, so we can
Yeah, because that's what confused me and Lee quite a bit, is that we looked at it and said, that doesn't look too bad to us. But Rob knows the site.
It doesn't look too bad, but it doesn't look right. I've never seen a river that's flowing that fast at the top, and that, the only time I've seen that kind of transition of, vertical variation of water speed as dramatic as that is where it's been a bidirectional flow with daylight wedge underneath.
Here's also the key, Rob, if you change that velocity plot down the bottom to vertical velocity, let's have a look at that, because vertical velocity should be 0. Vertical velocity on this is going to be number 3.
East, north. Yeah, up, yeah. There you go. Yeah.
And you might have to rescale it on the manual scale or automatic.
Yeah, I'll rescale it. I'll just make sure we're getting a good beam too. Beam 3. Is beam 3 okay? No,
yeah.
That was not. Yeah, okay. So, automatic. There we go. So we've got some quite horrible vertical velocities down here.
And you've got to ask yourself, why have you got vertical velocities of nearly half a metre a second down near the bed? This just doesn't make any sense whatsoever. That's just wrong.
Yeah.
But it's wrong because the two cells are not in the same place when you draw it up. So we got lots of bits of paper and drew them up. So one of the cells, if you look at that cell where you got the mouse there, one of those would be almost near the bed and the other one's quite near the surface. And when you work out the X and the Y and the Z velocity, they're not going to be in the right place. So it thinks that the water is going up. In fact, it's not. So we've got to get rid of that.
Yeah, so first of all, this site here, you'll notice on nearly every station, this sort of sunset symbol up here on the top left, I call it sunset, it's nice. It means that the ADCP is not measuring the depth. So all these depths are manual. And the guy who got this gauge in, it wasn't me unfortunately, but it's my station. So to get the ADCP to work, you can, if it isn't going to measure the depth itself, which it didn't, put in a manual depth and then it will measure. So it's a really good thing to get a measurement where moving boat measurement wouldn't physically get a measurement even if it would be any good. So all those have user input water depths in. So that was partly why I wanted to show this data. That's an option you can do. It doesn't matter what you're putting in the field, just stick in the depth and get some data and then put in a real depth there when you've worked out what the real depth should be.
You can manually survey the channel afterwards if you want to do a really good job, or you can estimate.
Yeah. I came back the day after and did another stationary gauging with the same distances and just applied the change. I applied the depth plus the change in stage sort of thing between the two to get the real depths for the day. Okay, so that's one thing, getting all the depths. So, as I say...
Sorry, Rob, did you change that top right plot from SNR to velocity? I think we were looking at it before as well, weren't we?
Velocity? That's velocity. Do you want this one?
That top right, that one there.
You want that velocity? Oh, yeah.
Yeah, okay. So we know, so number 1 is either is either X or east. Number 2, I have to think, is either Y or north. But 3 and 4 are the things that we're interested in. Maybe not so much number 4, the delta, but number 3 is the up-down velocities. Why is it increasing with depth? And it's all to do with pitch.
That green beam there. No, sorry, not a beam. That green depth there.
So in a good site, that would have been staying at 0.
Yeah.
Or in a good measurement.
So if you suspect these velocities are wrong, which they are, they're well negative biased, but this data is okay, then what you want to do is go to profile extrapolation. No, you don't. Yeah, you do. Yeah, you do. And at the bottom, 70% of the profile and apply to all or wherever you think across the river, and then okay. And we've got just this data now, extrapolating down using whatever fit you decide down to the bed, and that's creating your new flow. So that went...
Nice surface velocity measurement, Rob. That's what you call it.
I was just about to say I don't like this, but then, of course we all know it works.
I've done it times and it works quite well. It wasn't always because of this pitch problem.
But do you believe those values? Can you switch it back to water speed, and we can see?
Well, you know what?
Velocity console.
I think you were saying you were expecting about 80 QMex, or 78 to 80. And it's,
77. Yeah, yeah.
It's pretty good now.
So this was at this point the highest ever gauge in here, but last year I went back. Sorry, Sontek guys, but it was higher, and the M9 just would not work. I tried every single trick. I put it on 1 megs. I tried manual depths, and it just went blur, and I had to get the current meter out. But it was a pretty mental flow. It was up near 100 and near 5 meters a second there. So it just didn't. It wouldn't play. But it was good for this data, and they all line up pretty well when I put them into SCED.
And this data set almost here leads me back to one of the first pictures that Nick showed in his presentation. And I noticed there was quite a bit of pitch on there, which you don't want to do. You'll want to get that bomb a bit closer to the water to get rid of that pitch.
Yeah.
Or a bit more weight.
Yeah. Actually, I was hoping we'd have a few pictures of deployments and sites, but I mean, it's probably my fault if we haven't, because I was a bit late in asking Rob for that. But that's the kind of thing you can get from pictures is, the sort of pitch that we're talking about.
There's some good data from up in northeast, I think, on the Tyne, or was it at Reed?
And Ian Downs is on this call unless he's run away. Is he still here?
No, he's still here.
There he is. Ian, do you want to show us some of your data and talk through it?
And some photos, because we'd love good photos as well.
Especially when trees hit your cableway.
Yeah, unfortunately I'm on my laptop and all my data's on my Toughbook, so I haven't got any. I might have some pictures, but I think I've sent you guys most of the big level ones. So you might, if you've not got them, you were looking at one of them, weren't you, Nick?
I've got Reaver Hill on my laptop at the moment. Is that?
I think that one was in North Tyne. That was done during the flooding in February. The one on the big one on the Tyne was during Storm Desmond.
Well,
was it Reed? No, not Reed.
We have a Reed Bridge. I don't know if it's that one. Reaver Hill, Bywell.
Bywell, yes.
Yeah, Bywell was the big one.
Yeah, I think
I sent Nick Martin the Bywell one.
Is that the KY? It's a bit of a skew.
Yeah, it's off a cableway. The question that I had really about this when you were asking Nick Everard about you would use stationary mode all the time. When wouldn't you use it? I was just wondering if you've got a change in depth that's changing quite rapidly, a change in stage. Is that still good to use a station? Because obviously you could be taking half an hour, 40 minutes on a wide span to do a stationary one rather than 3 minutes, and the level can change quite a lot in that time. So I didn't know if that. I think on the Sontek one you can add the stage in for each panel, but I don't think you can on the section by section. But I might be wrong with that. But I couldn't work out how to do it if that's the case.
That's a good question, and I just switched screens to see if it gave me timing. It doesn't give me the time of these. Can you add things to this? Oh, there we go. Still doesn't have time. Oh yeah, start time. Yeah, so this one you started at 11:41, finished at 12:22, so it took 41 minutes. Well, what I was going to suggest on this is something I learned from the French. With their surface velocity measurements, I don't know what they do with stationary ADCP measurements, but for that reason and a couple of others, they tend to do a vertical, then skip one, then another, then skip one, then another, then skip one. They do every other one, and then they fill in the gaps as they come back across, and they do it for kind of that reason, so that in each crossing of the river, you've got enough data that if the batteries went flat or if something drastic happened, by the time you've got to the far bank, you've actually got a usable measurement, and then they improve that measurement if the conditions aren't changing too rapidly by infilling on their way back. So I guess you could try that, but if it is changing very rapidly, reducing the number of verticals is probably the thing, and I don't know, concentrate where the bulk of the flow is. Would be my suggestion, but
Nick mentioned about doing that from doing the panels, which I hadn't thought about. Just doing about half a dozen for the section in case it breaks or whatever. But that was during the stationary mode talk, and I haven't been out since then. But I thought it was a good idea, and if we were in that scenario again, that's what we would do.
But I think
usually I do mine like just split it off into 5, go across, get 5 panels in, and then infill on the way back.
Yeah.
So if anything does go wrong, and then maybe reduce it to 35 seconds.
But the important thing is, if the bottom track reference measurement isn't a good measurement, the time you've saved is time wasted anyway. So
yeah.
I mean, if you just got one if you just got one section, or even just 3 sections that were good with stationary, that's better than 10 bad transects with bad bottom track, and unless you can recover it with good GPS.
Yeah,
but I think for me the thing to do is just get a small number of measurements well spaced across the river, and then infill on the way back if you've the time and if it's not changing too much.
I think what's key if you're going to do that is ensure that you get a low velocity and a high velocity point. So it might, some people say, I'll do one at each edge and one in the centre as my minimum. That's not a bad idea, but better idea is the 2 edges and your high velocity point. So if your higher velocity is slightly to the left or right of the channel, get those to make sure you get a better mean calculation.
Yeah, that's an interesting point, because if I can find the right one, is it this one? Mark Randall shared a surface velocity video from his drone. This is the guy in Australia who's doing a lot of measurements with drones, and most of the river, I don't know why my computer's going so slow, most of the river was actually hidden by tree cover, so you could only see the middle 30%. But actually the discharge that we calculated by doing surface velocimetry of the middle 30% gave us almost exactly the right flow. It agreed within 1% of what the ADCP gave us. And it doesn't, for some reason, it doesn't look as though Windows Explorer is working. So you'll have to take my word for that. But yeah, that's the point is, get something that represents the slow water on either side, and then get some measurements that represent the fast water to get something.
But do you know if you can allocate a stage to each vertical then? And change. I think I'm sure when you fill it in the details on stationary you can, but I'm not sure.
Yeah, I don't know if it actually does anything to the measurement though.
It's supposed to wait.
You could add a note there, I suppose. But Rob, do you know if you can?
No, that's all. You can't. But I'm not as I think it was Nick Martin spoke. I don't think it does anything. Well, it doesn't change the discharge in stationary software either. It's just for you then to apply that difference in stage to your gauging. So, like doing a current meter gauge and take regular stages, and then somehow in whiskey later you're going to have to apply a mean stage, aren't you, to your gauging because it's taken so long.
We normally just use the average from the start to the end and put that in.
Yeah. That's it, yeah.
If you put in, so in our stationary software, you can, for every vertical, put in a gauge height, and it will link that to the time, and it will weight the rise and fall over time.
So just whilst we're looking at this set of data, I mean, this I'm not very happy with. I haven't seen this before with the River Pro, but I think this is a processing glitch as well, unless you have any knowledge, Ian, of some particularly strange velocity distribution at this site.
No, to be honest, it's not a site I'm overly familiar with. It was just a site that was given some high levels. I've only gauged it a handful of times, so and I think it's the first time we'd used stationary at it. So yeah, it's not one of my sites.
So you can see that in the velocity profile up here, that what it's reporting is a water speed that's fast close to the surface, and then it gets slower, and then comes to a point, and then suddenly gets faster again. And it seems to do that at a number of locations.
I mean, there was a lot of debris
reflection.
Yeah, it looks like it.
You think that's an acoustic thing, an echo coming off the bottom?
I could be. I'm not saying it is, but just knowing some of the problems we've had, it looks like that could be a bed reflection.
I'm afraid this is the only data I've managed to load, because I've got 3 instances of Section by Section Pro live on my laptop, and 2 of them have crashed and locked up. I can't load any more data.
You go to the intensity plot, Nick, and then right-click and change it to correlation. It might help. Ooh, there you go. So, yeah, your beams aren't seeing the same thing, are they? Same as the intensity looked a bit weird.
I wonder why do you think that's the case, Rob, for this? I mean, it's quite fast water. We've got water speeds of up to 3.7 meters a second. You know, for an English river, that's moving along a bit.
And you would, from what I just said, I wouldn't expect to see a reflection thing in that sort of speed.
Have you got some air on the back beams? Have you got a bit of pitch?
That's what I was wondering. How do we find pitch and roll here?
I think there could well be a bit of pitch on there. It was quite turbulent.
Anybody know where we find pitch and roll? This is an interactive learning experience.
Yeah, I don't know. If you
can't, basically.
Does it not record it, or?
No,
it must be there somewhere. If you go back to the samples tab or whatever it was, can you add in? Can you right-click on the top menu like you do with ours?
No, I don't think you can.
No, that's fixed.
Yeah, because I wanted to get out the GPS position, because you see the GPS positions are recorded here. And I thought, oh, nice. I can plot this in Google Earth by getting that out through this mechanism. And it doesn't put the GPS positions in here, and it doesn't allow you to add them either, which seemed a bit daft. But yeah, you'd think it would give you the pitch and roll.
Pitch, yeah.
Mm.
It does have a pitch sensor, doesn't it?
Oh, yeah.
The compass.
Yeah, it does, yeah.
Well,
no, I don't know. I'm going to put that on my enhancement list.
You might be able to get the information out if you BB sliced it and stuck it in Wind River 2, but you can't in this software.
Yeah, okay. Right, anything?
Could you go back to your presentation with those pictures at the start?
Yep.
Just to show that angle on there.
I am trying to go back to my presentation, but my computer is not playing ball. I can go to a Rivsphere Live. I cannot go back to PowerPoint. It's disappointing. Let me see if I can open it again from... where did I put it? Oh, there we are. There's quite a lot of pitch happening there, but the bomb's in the water.
Yeah.
But this one, I think, is the one.
The very
that one there. Yeah, where you got quite a bit of pitch, and that could all be cured if you got that bomb a bit closer to the water. Or on the torrent board, at least, there's 2 mounting points on there for where you can put the eyelets in, the toe-in eyelets. I think you got them tied off to the handles instead of actually into the mounting points on the board. If it's my one that you sent back, yeah. So you could move those mounting points, and there's 2 eyes that screw into the board. You could move them more to the middle.
Yeah. So this is the RS5, I think, isn't it? We were really just having a muck about to see what data we got, and and any tips, because again, I have no cableways in my patch, and I certainly don't have cableways in fast flowing water. So tips to try and improve it. So again, the bomb closer to the surface and tethering it.
And maybe a longer line on from between the bomb, and that might help out, get it a bit lower. And also, yeah, the tethering points, you can move them forward or aft as well. So to get that pitch down a bit, you're probably using the aft points, which is in probably a similar place to where you got it tied on.
There's if I just share this shot, I don't know whether you see it.
Oh yeah.
So there's the hydroboard. More importantly, it's about where the weight is, and I think this is from Bywell during the floods. Yes.
No,
Reed, is
that's
it?
Reed.
Okay.
Reed Bridge,
okay.
yeah, on the River Reed. Yeah.
Okay, but I would say that's a pretty good setup.
Yeah,
considering the velocities, that's really
better,
good.
Yeah.
Does
anybody else on the call have any?
We've changed that setup now, so we don't use it like that. But,
why change something?
Go back to that.
Yeah.
Well, we've got it so we've got a weight system where you can add or take weights off depending on what you want, rather than just attach them.
Okay.
So we use it like that.
Okay.
So we've been quite a long time on this, and I'm happy to keep going for a bit longer if people want to. But are there burning questions we haven't covered? Were there any things on Lee or Nick's list that Rob didn't cover? What's his mark out of 10? And also, perhaps most importantly, is there anyone else on the call who's got comments, questions, or best of all, some data that they want to share? And I noticed there's a little blob by the chat window. Somebody put something. Paul Griffiths put something. Oh, Paul said he's leaving. He's got to go. 5 minutes ago, Paul Griffiths has gone. See you, Paul. Right, responses. I'll be so pleased if somebody unmutes and says something now. I won't offer to buy them a beer because we can't because it's lockdown. But I'll buy you a virtual beer.
I can show you pictures of Bywell. I just haven't got the data from the floods, but I've got like a PowerPoint presentation of what kind of went on, and just with some videos, which I can show people if people care.
Pictures of conditions in which you've done certain measurements and the reasons why you've chosen to do them. When we get to site, all we have is our eyes, don't we? We look at the site and we think, what sort of measurement shall I do? So yeah, go ahead.
Okay, I'll just try and open it up. Right.
So just while I'm not seeing any pictures at the moment. I don't know why.
I think we're waiting for Ian to share.
I'm not even seeing yours. Oh, Ian's coming up now. One of the things that we, Nick and I, have asked for in the next version of the stationary and for the stationary in the RSQ is to give an alarm on pitch. We don't do that at the moment. But if we're getting to sort of 10 degrees, we're saying pitch, we should set up an alarm that becomes visual on screen for the user to sort of make you think about that a bit more, because it's really important.
Go for it, Ian. What are we looking at? I mean, that looks a pretty good setup. You've got the pitch pretty low. Although I notice you've stretched the photograph to make it look as though it's flat. It actually is.
I'm not sure. Well, we'll see it unstretched. That's just for the picture. But yeah, so this was during the Storm Desmond, obviously. So it's getting on for 5 years old. But we're still, as it was the biggest gauging ever done in the UK at the time, we're still milking it. So it's. So this is when we kind of turned up at site. It's a shame I haven't got a photograph so you could kind of see what it's normally like, because there's like about 3 sets of steps to get down to the channel that you would normally walk to there, and the height's normally about 0.5 generally, and when we arrived it was getting up to 6 meters. So lots of debris and things hanging around the site. So we got in. This was the same site that you might have seen on Yama, where the tree took the cableway out just in February. So it's but the level was actually higher here than it was in February. It's just the trees were smaller. So there's a similar setup. So yeah, we just have that weight kind of set. So the hut's got like a sliding door, so the weight we keep that weight attached, so you can just kind of move it out, and it's so you don't have to kind of keep lifting the weight all the time and connecting it onto it. So we've got a video of this. Let's see it. So we'll see if that actually works on these. So click on it. Is it going to work? It's not looking promising. Yeah, it's a shame. So anyway, that was the result of what we got. So and this was one of the first times we'd used stationary mode, so 5 years ago. So it was like putting it to the test. So and it seemed to work pretty well.
Highest level since the Great Flood of 1771.
Yeah, that flood wiped out every bridge on the River Tyne other than one in Corbridge. So it took out the original Tyne Bridge at Newcastle and everything. So it was so yeah, and that was before Kielder Reservoir was in, obviously. So which will have held some of the water back. So yeah, it was pretty significant. Yeah, this is where we had a slight issue, and we kind of lost the M9. We just finished the gauging. So we got it to the far we finished it, got it to the far bank, but the wind blew it out the water and put it in upside down because we were kind of thinking we were going to do one moving boat measurement, bringing it back just to see how it would compare. But in the end we couldn't so we had to drag it back, and then just as we'd got it, we were literally lifting it out, and the little well, we think it snapped or it came loose. You know, the little triangular grip up that the ropes are on.
Right, yeah.
It was, so now we just put it through that rather than put it through the rope as well, which we always do now. So it kind of drifted off down the river, just got caught in this. So it looks like you can kind of get out to it and get it. There was a nice video there showing it, but sadly it won't work.
Was that one of your guys swimming out to get it?
No, so we spent absolutely ages. We had in the end we had a 6-meter E-staff with a claw hammer attached to the end, and managed eventually to drag it back in without getting there. So and then one of the lads the lad I was with took it back to his house and put it next to his Arga overnight, and then we had it out working again the next day. So it was a good advert for Sontek. And then so that's the height it was when we left site. So it was dark by the time we spent more time trying to retrieve the M9 than we did actually on site gauging with it. But yeah, and it peaked just below 7 meters, so it was still going up. And by the time we came back the next day, it had been right up and was dropping back down again, and it had been up into the building, deposited this tree here, and this had just put the silt everywhere. So all of the generator, the boxes, they'd all moved away. It was only a small, where that black line is the water level, but that much water kind of it kind of shows if that was in your house, it's pretty grim. So it spoiled it for you there by ending with a stream crawl for the Sontek thing, picking up the Sontek thing and then end up with a stream crawl. Wow. Anyway, so
excellent. Yeah.
That's that. So
you want to get
the video
control here, and that looks quite Larry.
Yeah, it's a shame the videos didn't work. I don't know why that was, but it's on the system way.
So when you get a high flow at that site, do you normally use moving boat, or do you normally use stationary now?
No, now we would just automatically use stationary. But that was where we got hit by the tree and got the cableway wiped out. Possibly if we'd have done what Nick had kind of suggested and what you'd suggested about doing a few points, because we were probably about a third of the way along. So in that time, we might have got enough to get some kind of data rather than, come away with a broken cableway and no gauging. So it was kind of a bit of a lose-lose situation.
Yeah. One thing that we didn't show today in our software was just taking out some panels, and just comparing the discharge. But you can do that at your own leisure. Just have a 20 panel gauge and then go down to 5 and just see the difference on the discharge.
Yeah, it could be interesting.
You'll probably find it's not much.
I think I've got a data set here we could do that with. I don't know whether people want.
Shall we have a quick look at that and then wrap up unless there's anything else burning? Because we've been some time. Obviously, it's all been high quality and interesting stuff. But do you want to take this?
I'll very quickly show this video, if the video works. Do you see? This is a cableway in Spain. Do you see that on your screen?
I do. I see a huge amount of pitch. It's not moving, but
It's yeah, okay. The video's not running yet, but no. Do you see it now?
Yeah.
Yeah.
So that's it's horrible. It's perfectly flat water, but it is running at around about 3 meters a second.
Is that a manned cableway?
It's a manned cableway that has actually got an automatic. So they now don't allow a man to stand inside it. So it's just on a powered winch. But really, they should have been putting a weight in down here, and then they'd have got much better. Though, as much as I keep...
They've clearly shot this video with a drone. They could use that for safety. So they've got some nice surface features.
They have, yeah. But much as I've been beating on about, get your pitch right, the discharge, according to the rating and everything, and the measurement here with the ADCP on the moving boat, it was less than less than 5% difference. So there is some sort of, sometimes it's just better to collect some data than to spend all day trying to get it perfectly right. Yeah. Right, let's just get this measurement.
Lee, sorry,
at least in a news. Go, Rob.
Have you got my? Yeah.
Lee, if you say you didn't do depth cell mapping, is there any plans to do that? And then the pitch issue might not be a problem apart from for depth.
Well, it would still be a problem if we don't use a 3-beam solution, because you'll have one beam that's giving 0 velocity, and that will be obviously giving biasing you low, whatever. And that's their reason for not doing their main reason for not doing cell mapping.
Why can't they? But they must be able to do the maths to figure out the impact. So it's the same with depth.
But
the fact that depth is not compensated for pitch and roll on either ADCP, as far as I know. Well, when I say either, I mean Sontek or RDI. But it's surely doable. If you know what the pitch is, you're getting readings that you could then correct.
But you won't get any Doppler shift is the thing, because one of the beams will be going down to the bed, so it will be at right angles to the flow.
Well, only if it gets to 25 degrees. If it's only at 12, it's going to be a reduced Doppler shift. But you're going to get
falling apart massively at a certain degree, is what they're saying.
But aren't you going to get an enhanced Doppler shift on the one that's...
The one going forward would be great.
Wonderful. Yeah,
I'm sure with some creative thinking, there's something could be done with that. But Lee, were you going to show us removing some?
Yeah. So do you see my stationary on your?
No.
Okay.
Did you share application?
I'm going to have to share a different window.
I think if you share screen, it will show whatever's on your computer.
Looking better. Yeah.
Now we can see it.
Get it now? Yeah. Okay. So this is So this site with all the profiles added. So we sort of see that the peak velocity's left of centre. So if I just I start unchecking.
11.24 to start.
Yeah, 11.2. Yep. I start taking these out.
Did you rehearse this one, or did you choose?
Of course I did. I wasn't going to just. Okay, so all I've left in there is 2 at the edge, so we get a better mean of those two. 2 at where the peak velocity was, and 2 again at the far edge, leaving those in, and we got 10.7. Okay, which is I did work that out. It's 4.6%, 4.6% off of what the putting them all in was. So then if you then start adding in.
Oh, Lee, hold on. If you got the PDF that shows your uncertainty, because it will tell you your uncertainty is really bad.
Not that bad though, Nick.
Oh, it's not that bad. Is it?
It's not.
What's going on there?
Yeah. It's but I was just using it really just to sort of say, show how, you know, but and the worry is, if I hadn't have chosen that bit where the faster flow was, if I'd come, say, over here to the centre of the channel, that's centre? No, that's not centre. So how wide are we? 28, 0 to 28. So if I go around about 14 metres, 2 in the centre, yeah, it's not. It's 10.1. I use the 2 where the peak velocity were. We have 10.7. But it starts to significantly improve. Obviously, the more data we put in. But we were still at 5% in just taking 3 panels, in effect.
So I've just, within, I think it was your data, wasn't it, in Reaver Hill? I've just taken that, stripped that down to, I don't know, I could share my screen if you like, about 8 panels, and it drops from 526 to about 513. It makes hardly any difference.
Good site, must be.
Good
location.
Yeah, but you could do that test though. That's the point. You could, you know, for measurements you've already got, section by section ones or stationary ones. You know, if you take out verticals and see what difference it makes, you know, you could perhaps even come up with some optimal distances. So for Bywell, which is a site you know you're going to want to hit a few times when it's high. You know, if you know that you get a really representative discharge, if you get one vertical at 5 meters, one at 25, one at 40, and one at 75, whatever, you know, you could figure out the key locations across the river. If you really got to hit it fast, get them in the bank, and then you know, infill or just move on to. But you could do that for any site where you've previously done a high flow gauging with section by section or stationary. You could do that analysis and figure it out. If we've learned one thing today, that would be a really nice thing to say, which immediately makes me feel bad because Rob's been quite quiet for a little while and Rob's led most of this, and I think Rob's done a really, really good job. So unless there's anything else, any final questions, anything that you've been itching to ask?
We've not said that in the sorry, it is a bit of a plug, but it's with the GPS positioning.
Oh yeah, no, that is. I will allow you to talk about GPS positioning. Then Nick, I'll need a cup of tea.
Yeah.
Nick, do you want to take the screen, or is?
Yeah, I'm going to stop sharing.
Have we got? I don't have any on ready to go at the moment. I can do. I can get my mouse to work. Nice.
Because you know this is really, you know, a big help. You know, if you can't get
Keep talking, Lee. I'll find some data.
If you can't get a cable across the river, you know, if we don't have a cableway there, or you know, it's just too wide to do a bank to bank with a rope or whatever. Then you know that's when stationary really does start to become a real pain. You know, if you've not got a bridge, you know, or you've got a bridge that's got so many piers on it that it's disturbing the velocity so much that it becomes almost meaningless.
We almost need a separate session on the practicalities of stationary modes, don't we? But we won't.
Yeah, we won't. But unless people want to talk about it,
come on, find some data, guys. I mean, the basic principle of what Lee's talking about is that if it's difficult for you to get your locations across the river, you know, their software now has the ability to use real-time GPS information to know where the boat is. And to know if it's moved. So if whilst you're measuring it, and correct me if I get any of this wrong, but you know, whilst it's measuring, if it drifts upstream a little bit, it knows that, and it will correct the velocity for that. But it will give you the distance spacing across the river. You talk about it, Lee, because you know, and I'm just trying to make it up.
If you don't have what Nick's probably going to talk about with virtual anchor, if you're just holding it with the arc boat visually by your eye. Again, you'd have to check that you haven't got a moving bed. But if you're doing it like that and you've no moving bed, put it onto bottom track so that it actually takes a good mean from its position and everything. That would work. But even better, if you could have one that has the autonomous added onto your boat, You're doing that on yours, aren't you, Nick? Or Wallingford are?
What, me?
No, Wallingford.
Yeah,
I'm sorry.
Wallingford.
Are Wallingford put in autonomous on the?
Yeah,
it
should come. I mean, yeah, we're
okay, but the virtual anchor is as Nick
part of the autonomous package that we do with the ArchiPod. So if you have an ArchiPod and you want to upgrade it for autonomous, which is usually used for doing bathymetric surveys, we just send it out on a mission. But we've got to have a feature called virtual anchor on there where you drive it to a place, flick a switch, and it just holds position. But you do some caveats in there. You need a velocity in the river, maybe over 20 centimeters a second, and you need a good view of the sky as well for it to hold position. But it works pretty well. You know, the wider the river, the better it works.
But are you going to show some data?
Have you got something to show us? Or?
The GPS.
I'm trying to find some.
Oh, sorry.
We'll have to time out.
Yeah, we will. Yeah.
Yeah, sorry.
Yeah.
Well, I know we talked about it in the previous webinar on this.
Well, shall I wrap this up then? I mean,
yeah, please.
We'd like. Yeah. All right. Well, thanks very much, everybody, for joining. Thanks very much to Rob for leading most of this. Thanks to Lee and to Nick for your contributions, which have been very valuable. Hopefully you've learned something. I know I have, and I want to go and measure on some rivers where I actually need to use it. So if anybody on this call wants a hand next time they get a flood and they've got some cableways and some fast flows, give me a shout once it's safe to do so, of course.
And
otherwise,
if anybody out there hasn't, for whatever reason, not been able to talk or be able to talk about a problem they've got, do send us some data, and we'll have a look at it for you. No problem with that.
Yeah, and if you've got something you think needs to be added to my enhancements list, then let me know, because I'll put that together. But yeah, I think that's it then. So thanks very much, and I'm going to close this, and hopefully it's been recorded, and if it has, we'll share it. It said it was recording, so could be. So thanks everybody. Enjoy the rest of your day.
Great, thanks.
Cheers, now.
Thank you, everyone. Thank you. Thanks very much, Rob. Really appreciate that.
No problem. Thanks for your help.
Okay. Bye-bye.